All right, so we're going to talk today about the beginning of our unit on atoms. So what is an atom? We learned in first unit that matter is made out of atoms. So the atom is the smallest particle of an element that retains its identity in a chemical reaction. So we're able to recognize chemical reactions because we can look at how the atoms are changing. So we're going to start with our first model, and that is by Democritus. Democritus lived in well before anybody else, 400 BC, and he said that atoms were indivisible, so could not break them down, and they were indestructible. Democritus had a major flaw with his model because he said that, we have these things called atoms, but he had no data to support it. What he thought is that if you take a piece of matter, let's call it a square shape, and if you cut it in half, and cut that in half, and keep cutting that section in half, you would eventually come up with an area that you could no longer divide, hence the indivisible, and that was his atom. He didn't base this on the scientific method, nothing. And he was shot down by philosophers who had more money and were better thought of than Democritus. So if we were to draw his model today, we would just draw it as a circle with nothing inside. We'd shade it in to show that it was indivisible. So if we fast forward a little bit, we come up with our next model, which looks identical to Democritus, and that is by John Dalton. So 1800s, we have a long time that passed. Now Dalton's model of the atom was accepted because he actually did his experiments and had quantitative data. So he has 5 parts to his theory when he looked at atoms, 5 postulates. The first postulate, all elements are composed of indivisible. So there's that same term, indivisible particle called atoms. Postulate 2, atoms of the same element are identical. The atoms of one element are different from those of any other element. Number 3, atoms of different elements can be physically mixed together and can chemically combine to form compounds. So how are we making a compound? Versus how can we just mix them together? When chemicals form, they form in whole number ratios. So if you have one atom and it forms with 2 atoms of something else, you have to have a whole number because he stated atoms are indivisible. You could not divide them. Number 4, chemical reactions occur when atoms are separated, joined, or rearranged. So he goes on to show what a reaction is. And number 5, the atoms of one element are never changed into atoms of another atom as a result of a chemical reaction. At the end of the unit, when we talk about radioactivity, we're going to talk about a special circumstance where this does happen. So at the time, Dalton had a certain amount of technology he was able to use. However, 2 of his postulates, were false. We've since then discovered. It's that term indivisible. We know that there's things inside of our atoms: protons, neutrons, electrons. The second part is identical. We have things called isotopes. Isotopes like carbon-12 and carbon-14. They're the same element, but they have different masses. 3 out of 5 of his postulates are true. 2 of them are false. So on a test, you would need to tell me which ones are true, which ones are false. You don't have to restate them. I would give this to you more as a multiple choice question. All right. So Dalton isn't where we ended because we know that there's stuff inside of our atoms. So we go on and we go on to the late 1800s. J.J. Thomson. He gets credit with the electron. So he used this cathode ray tube experiment, which you'll see, to identify that there's these negative particles called electrons. Most people don't know what a plum pudding is unless you're in Europe. So we use the term chocolate chip. So over here we have a model called our chocolate chip cookie model. And the chocolate chips are your electrons, E with a negative sign as its superscript. And he said, okay, there's electrons. They're somewhere in the atom. They're just randomly dispersed. But the background, the cookie part, is your positive charge. Okay, great. We have an electron. The smallest particle in our atom was discovered first. Kind of ironic. The next part that was discovered was our nucleus, our positive center. And this discovery was made by Ernest Rutherford about a decade and a half later after the electron. And his experiment is like the activity we completed in class where you're rolling the marble underneath the board. He used gold foil, a very, very thin piece of gold foil, and he shot alpha particles through. And he was looking at how the alpha particles were deflected. So he assumed that there's this positive center called the nucleus. And our electrons are still around. They're just outside of the nucleus. So Thomson had a positive background. He didn't know what it was. Rutherford said, okay, I know what that positive background is. It's a nucleus, and it's smack dab in the center. Our nucleus is very small. It's very dense. And the electrons have a whole lot more space that they can move around with. Now, just in summary, our subatomic particles are what's inside the atom. We have a proton. We indicate it as P positive. We have a neutron, N superscript 0, and our electron, E negative. Our proton has a positive 1 charge. Our neutron is neutral, so 0, and our electron has a negative 1 charge. Its mass is 1 AMU, atomic mass unit. It has a mass in grams, but it's really small. A neutron is also 1 AMU. They're almost identical masses in grams. And using this atomic mass unit, an electron we are assuming is 0. Its mass is so much smaller than the proton and neutron that when we convert it into these AMU units, it's pretty much not there. Our proton is in the nucleus, as is our neutron. And our electron is outside the nucleus somewhere. Up until this point with Rutherford, we have all those subatomic particles discovered. The proton and the neutron were discovered just a couple of years after the nucleus. So what we're going to focus on when we come back to class is where the electron is located.